Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll graph a trigonometry function. As per the problem, sketch y equals secant x. As you may know, secant is the reciprocal ratio for cos. Secant x is equal to 1 over cos x. So the graph of secant x is derived from the graph of cos x. This is a very important concept we need to understand and memorize to graph a secant function. Let's start by sketching the cos x function. The maximum value for cos x is 1. The minimum value is -1. We can sketch a full cycle for cos x function from x equals 0 to x equals 2 pi. We can use the key points 0, pi over 2, pi, 3 pi over 2 and 2 pi. At x equals 0, cos x is equal to 1. At x equals pi over 2, cos x is equal to 0. At x equals pi, cos x is equal to -1. At x equals 3 pi over 2, cos x is equal to 0. At x equals 2 pi, cos x is equal to 1. We can join these points in the form of a wave to sketch the cos x function. This is the sketch of cos x function from 0 to 2 pi. Now we can use this graph to sketch secant x. The graph of secant x has vertical asymptotes. These vertical asymptotes are at x values where there are x-intercepts in cos x graph. In this full cycle that we sketched, the cos x function has x-intercepts at pi over 2 and 3 pi over 2. So we can draw the vertical asymptotes for secant x at pi over 2 and 3 pi over 2. The graph of secant x is a collection of curves between consecutive vertical asymptotes. The period of cos x function is 2 pi. So the period of secant x function is also 2 pi. Between these vertical asymptotes at pi over 2 and 3 pi over 2, the cos x function forms a trough at x equals pi. Therefore, the curve for secant x function between these vertical asymptotes is a curve that looks like a parabola that has its maximum point at x equals pi and y equals -1. So the point pi -1 lies on both the cos x function and secant x function. We can show the curve between these vertical asymptotes like this. On the left and the right side, the curve goes down along the vertical asymptotes but don't touch them. So this is the curve between the vertical asymptotes at pi over 2 and 3 pi over 2. Now we can show the curve from 0 to pi over 2. Since there is a vertical asymptote at pi over 2, on the left side of this vertical asymptote, the curve for secant x will go in the upward direction, because on the left side of pi over 2, the graph for cos x forms a peak at x equals 0 and y equals 1 at point 0, 1. So the curve for secant x looks like a parabola that opens in the upward direction and has a minimum point at 0, 1. So the point 0, 1 lies on both the cos x function and secant x function. We can show the curve like this. If we want, we can extend the curve on the left side of the y-axis. It will go up along the vertical asymptote at negative pi over 2, because in the secant x graph, the vertical asymptotes are pi units apart. We can verify that by subtracting pi over 2 from 3 pi over 2, which is equal to 2 pi over 2, which can be reduced to just pi. So this distance is equal to pi units. So the next vertical asymptote for secant x on the left side of the vertical asymptote at pi over 2 will be at negative pi over 2. This is how we can keep extending the graph of secant function on the left side and the right side. So the curve on the left side of the y-axis will look like this. Similarly, the curve for secant x between 3 pi over 2 and 2 pi will be a curve that looks like a parabola opening in the upward direction, because at 2 pi the graph of cos x forms a peak. The peak point lies on the cos x graph and secant x graph. We can show the curve like this. And if we want, we can extend the curve on the right side of 2 pi the same way we extended it on the left side of the y-axis. So these are the steps you have to keep in mind to sketch y equals secant x. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.